Good day, ladies and gentlemen. In this video, we will discuss wood and wood products in construction materials and testing. I am Lian de la Peña and allow me to discuss with you what wood is and its properties. So, what is wood? Wood is a hard, fibrous structural tissue found in the stems and roots of trees and other woody plants. So we can find wood in trees as it can be a tree's stem, roots, or branches. Wood also consists of lignified tissues or plant tissues that contain lignin. Lignin is an organic polymer that strengthens and supports plant cell walls. That is why wood is hard and is responsible for the protection of plant cell walls. The next one is timber. So why do we have to include timber? Timber is also a wood, but in its semi-processed form. As you can see in the picture there are already cut down trees that are being exported. These are called timber and they serve as raw materials for wood products. When timber is being processed, the product is called lumber. Lumber refers to the processed wood and can be used as a building material. Okay, so now let us try to go back in time. Here is a brief history of wood as a construction material. Who else among you has an old house made of wood? Or have you seen old structures made of wood that are still standing and in perfect shape today? For over 10,000 years, wood has been a key building material. An example of this during the prehistoric times is the long houses in Neolithic Europe. During ancient civilizations, the Chinese wooden pagoda was also built using wood, and until now it is standing tall and proud. During the Middle Ages, castles in Europe also utilized wood to build structures. And lastly, wood was also used during the Industrial Revolution to build factories and warehouses. Now let us proceed to the properties of wood, wherein we are going to discuss its physical and mechanical properties. So, why do we have to study the physical properties of wood? It is because we need to understand and consider this, especially when choosing the type of wood to be used in building our structures. Knowing this will help us identify which is in good condition and what is best for our designs. The first one is the appearance of wood. It is the first thing that you will notice when you look at wood. And under this is the color of wood. So wood color varies from very light to nearly white to dark shades of brown and black. In the picture, you can see examples of trees with their respective colors. In these trees, they have their chemical extractives embedded in their cell walls, creating a unique color of wood. So these chemical extractives are the substances that can be dissolved from a material using solvents. An example of these include waxes, fats, or sugars. Wood color also changes with age. An example of this is freshly cut wood, wherein the surface of the wood slowly oxidizes when exposed to air. There are also some types of wood that are photosensitive, where exposure to ultraviolet light alters more of the extractives. So, the next type of wood appearance is the wood texture. This is what you feel when you touch the surface of the wood. Or you can simply identify this just by looking at the wood. Some natural factors, like grain direction and the sizes of wood pores, can affect the wood texture. Sanding or the use of sandpaper to smooth the surface of wood is also one of the factors. And the last type of wood appearance is the wood grain. These are the patterns of fibers you see in a wood, and it has four types. The first one is the straight grain, and as you can see in the picture, the pattern follows the trunk's axis. The straight grain means straight pattern. The next one is the wavy grain, which creates wavy patterns or sometimes creates curly shapes. For the irregular grain, these are the patterns that have knots that are surrounded by wavy pattern in no direction. And lastly is the interlocked grain. The cells spiral along the trunk, changing direction every few growth rings and creating a ribbon pattern. So we can usually see this in plywood, right? Have you seen one? And now the question is, does wood grain affect the strength of wood? The answer is yes, it does. Wood is the strongest when forces are applied along the grain, and it is weaker when forces are applied perpendicular to the grain. It is because wood fibers are arranged parallel to the grain, allowing them to support each other when forces are applied in the same direction. Those wood that receive forces perpendicular to the grain are more vulnerable to stress. So the next physical property of wood is its moisture content. This refers to the amount of water present in wood and can be solved using the given formula. For us to obtain the dry weight of wood, we must oven dry it at 100 to 150 degrees Celsius until it reaches its constant weight. So, there are also two types of moisture in wood, the free water and the bound water. Free water is the liquid or vapor that can be found in cell cavities, while bound water is attached to the cell walls. Attached here is a picture of a magnified wood section wherein we can visualize more clearly the location and difference between free and bound water. So in this property, there is also what we call the fiber saturation point, or the point at which only bound water remains. And in general, the fiber saturation point of wood is from 25 to 30%. So we will know more about FSP, or the fiber saturation point, as we move forward to the third property of wood, the shrinkage of wood. So, shrinkage refers to the reduction of wood's dimensions as it loses moisture. So this happens because wood fibers contract or break from each other when the moisture in wood is no longer available. And when wood dries, it loses free water first, then bound water. So what will happen to the wood if bound water is no longer available? The wood will shrink. Shrinkage happens when the FSP of the wood drops below 25 to 30%. This means not enough moisture is left to hold the fibers together, causing the wood cells to collapse and create changes in dimensions. So, wood is anisotropic, or it has different physical properties in different directions because the direction of its fibers may vary. Shrinkage in wood may happen in three ways. So, the tangential, or the shrinkage that follows the direction of the growth rings. It is said to be the most vulnerable part of the shrinkage. And the next one is the radial, or from the word radius, this shrinkage happens perpendicular to growth axis. So moderate shrinkage can only happen in this direction. Lastly is the longitudinal direction, or shrinkage along the grain. Shrinkage in this direction is minimal because fibers in this direction are stronger as it is parallel to the grains. The fourth property of wood is the specific gravity. It is the measure of the density of wood relative to the density of water. So this can be solved using the given formula. Knowing the specific gravity of wood is important to determine the weight and strength of wood. So most wood species range from 0.3 to 0.9. However, some tropical hardwoods like mahogany, nara, and malave can exceed 1.0. This means that they sink in water because the higher the specific gravity, the denser and the stronger a wood is. And another property of wood is thermal conductivity. Thermal conductivity is the ability of wood to conduct heat. However, wood is a poor thermal conductor, which means it resists heat and it makes it a good heat insulator. This means that wood does not allow the passage of heat. An example of this is building a house made of wood in places that experience winter because wood keeps homes warm in winter and cool in summer. Electrical conductivity, on the other hand, is a measure of how easily electric current can pass through wood. So, the electrical conductivity of wood is low when dry and higher when wet, because water can also be an electric conductor. Lastly is the combustibility of wood. This refers to the ability of wood to catch fire and burn. Wood is a combustible material, therefore it can ignite and sustain fire. That would be my report, and thank you.
Mechanical properties of wood. Number one is the orthotopicity. It is the uniqueness of the mechanical properties in the direction of three mutually perpendicular axes: the longitudinal, the tangential, and the radial. So wood is classified as an orthotrophic material because its mechanical properties are different along three mutually perpendicular directions, which is the longitudinal, the tangential, and the radial. So the longitudinal direction runs parallel to the wood fibers and is the strongest and stiffest, making it ideal for structural support. The radial direction extends from the center of the tree outward, while the tangential direction follows the curve of the growth rings. So due to this natural arrangement of woods, it responds differently to forces depending on the direction which they are applied, affecting strength, elasticity, and dimensional stability. Number 2. Elasticity. It implies that deformation produced by low stress are completely recoverable after loads are removed. When loaded to higher stress levels, plastic deformation or failure occurs. There are 12 constants that are needed to describe the elastic behavior of wood. Elasticity refers to the wood's ability to return to its original shape after being deformed by a low level of stress. However, if the stress exceeds a certain point, the wood may undergo permanent deformation or fail. Because wood is orthotrophic, describing its elastic behavior requires 12 constants: the 3 modulus of elasticity, the 3 modulus of rigidity, and the 6 Poisson's ratio. So the 3 modulus of elasticity. It is determined from bending rather than from actual tests of wood. So first, the longitudinal modulus of elasticity, which is denoted as E sub 1, represents the stiffness of the woods along the grain and is the highest among the three. It is the most relevant when the wood is used as beam or column. The second one is the radial modulus of elasticity, denoted as E sub 2. Measures stiffness across the growth rings and is much lower than E sub 1. Lastly is the tangential modulus of elasticity, which is the E sub 3. It evaluates stiffness around the growth rings and is the weakest, making it significant for analyzing swelling and cupping behavior. The 3 modulus of rigidity, also called as shear modulus, indicates the resistance to deflection of a member caused by shear stress. So the modulus of rigidity describes the wood's resistance to shearing forces. The first one in the modulus of rigidity is the longitudinal radial shear modulus, denoted as G sub 1, 2, measures resistance between the grain direction and outward from the center. Next one is the longitudinal tangential shear modulus, denoted as G sub 1, 3. It is important in resisting twisting forces along the grain. Lastly is the radial tangential shear modulus, denoted as G sub 23, reflects the behavior within the surface of the wood, particularly used in plywood or veneer applications. Now is the 6-Poisson's ratio. The ratio of transverse strain to axial strain. When a member is loaded axially, the deformation perpendicular to the direction of the load is proportional to the deformation parallel to the direction of the load. So, Poisson's ratio describes how wood deforms in one direction when stress is another. For example, when wood is compressed along the grain or its longitudinal direction, it may expand in the radial or tangential direction. So it represents by V sub 12 and V sub 13, respectively. Conversely, when wood is compressed radially or tangentially, it may also expand or shrink longitudinally or in the perpendicular direction, represented by V sub 21, V sub 23, and V sub 32. These ratios are crucial in predicting dimensional changes under different loading conditions. The third one is the strength. It is defined as the ability of a member to sustain stress without failure. The following criterion is considered for the determination of the strength of wood. So strength is the ability of wood to withstand forces without failing. And it includes several specific properties that describes how wood performs under different conditions. In that specific properties, we have the hardness. It is the resistance to denting and wear. It is the resistance to indentation using Hanka hardness test, measured by the load required to embed an 11.28 mm or 0.444 inches to half of its diameter. So hardness is the wood's resistance to denting or surface wear and is measured using the Hanka hardness test. So in this test, a steel ball is pressed into the wood and the required force indicates the hardness. Harder woods like hickory or maple are used in flooring and furniture where surface durability is important. To further understand what a Hanka hardness test, we have this figure. So, Hanka hardness test is a method of measuring the hardness of wood by determining the force required to embed a steel ball halfway into the wood sample. The higher Hanka rating, the harder and more durable the wood is. This test is particularly used in the flooring industry because it helps determine how well a wood species will resist denting and wear. So, how does this work? The steel ball with a diameter of 11.28 millimeters is pushed into the wood sample until half of the ball's diameter is embedded. So what does it measure? The force needed to embed the ball is measured, and this force is recorded as the Hanka hardness rating. So what does it indicate? A higher Hanka rating means wood is harder and more resistant to denting and wear. So it is important because Hanka ratings are used to help homeowners and woodworkers to choose the right wood for different applications, especially in flooring and furniture where durability is important. Next is the stiffness. It is the resistance to deflection and bending when loaded. Stiff woods are not necessarily strong. They may resist bending up to a point and then break suddenly. So it means that stiffness refers to the resistance of wood to bending and deflection under a load. It is closely related to the modulus of elasticity. Stiff wood may bend under pressure, but that does not always mean it is strong. It may still break suddenly under high loads. Next is the toughness. It is the resistance to shock loading. Tough woods will deflect before breaking. Even before fracturing, the fibers tend to hang together and resist separation. Toughness is the ability of wood to absorb energy and resist impact or sudden force. Tough woods can bend or flex under stress without immediately breaking. This property is important for tool handles and athletic equipments. Another one was the resistance to warping. Warping is the twisting, bending, and bowing distortion shown by some woods. It was greatly affected by the method of sawing and curing. Warping includes bending, twisting, and bowing of wood caused by uneven drying or moisture exposure. Wood that resists warping maintains its shape and is more suitable for applications requiring dimensional stability. Warping is influenced by the method of sawing and drying process. Next is the nail holding resistance. Nail holding resistance for hardwoods is greater than the softer woods. However, woods that are so hard that they tend to split when nailed lose much of their holding ability, pre-boring to 75% of the nail size avoids splitting. Nail holding resistance describe how well wood retains nails driven into it. Hardwoods are better in holding nail than soft woods, but extremely hard woods may split when nailed unless pre-drilled. Proper nail holding is also important in construction and cabinetry. Workability. It is the ease in sawing, shaping, and nailing. It is more evident in soft, low-density woods than for hardwoods, but usually they cannot be given a high polish. So workability refers to how easily wood can be sawn, nailed, planed, or shaped. Soft woods are usually easier to work with but may not provide a smooth or polished finish, while hardwoods are harder to cut but can be finely finished and are preferred in furniture making and detailed carpentry. Another one was the natural decay resistance. Resistance of wood to decay caused by extreme environmental conditions and termites is a good criteria of the strength of wood. Some wood species have their natural chemicals like oils and resins that protect them from fungi, termites, and other forms of biological decay. Wood such as cedar, redwood, and teak are known for their high natural resistance and are commonly used for outdoor structures and marine applications. Lastly was the paint holding ability. Discoloration of wood due to time is a great deal for maintaining the beauty and aesthetics of wood. Paint holding ability determines how well a wood surface accepts and retains paint over time. Woods with lower resin content and smoother surfaces generally hold paint better, and this property is essential in applications where appearance and long-term maintenance are important, such as exterior and interior finishing.
Good day everyone, I'm Lilith H. Angeles, and now let's proceed with the classification of wood, which are natural wood and engineered wood. So natural wood refers to wood in its raw, unprocessed state, harvested directly from trees and retaining its natural grain, color, and texture. Unlike engineered wood products like plywood or particle board, natural wood is not combined with other materials. So, the moment we cut down a specific tree, and it remains untouchable, it is considered as natural wood. Engineered wood, on the other hand, which is also known as composite wood or man-made wood, is a broad category of wood products created by binding or fixing wood fibers, strands, or veneers with adhesives, often under heat and pressure. It offers enhanced strength, stability, and dimensional control compared to traditional solid wood, making it suitable for various applications including construction, furniture, and flooring. So it is basically a natural wood mixed up with adhesives or glues like urea formaldehyde or UHF, which is commonly used in making particle board and plywood. Wood processing involves transforming raw wood into various finished products through a series of steps, from harvesting to final product manufacture. This process takes us from the forest to finished products. As you can see in the pictures, it starts with cutting down the tree, then transporting those logs to a sawmill or a factory where there the logs are broken down into rough lumber. Next, we season the wood to remove moisture, then shape it into accurate sizes. Then lastly, it is turned into usable products like furniture, instruments, or construction materials. Now let's talk about what makes each type of wood different. These are the physical properties. Things like wood rings or the circular pattern that you can see on the top left picture can show the age of the tree and how fast it grew. We also look at color, depending on the type of tree and affects the look of finished products. Then there's grain. That is the texture or pattern in the wood, and it changes depending on how it is cut. And lastly, knots. Those little circles can either add character or be a weak point in the wood because knots can reduce how much weight the wood can safely hold. Let's move on with the classification of natural wood, which are hardwood and softwood. Hardwood refers to wood from deciduous trees or trees that lose their leaves seasonally, which are typically broad-leaved and have a more complex internal structure than softwood. These trees often have a stronger, denser wood than softwood, making them suitable for various applications like furniture, flooring, and other durable items. So now we're diving into hardwood, which comes from deciduous trees or the ones that lose their leaves seasonally. Hardwoods usually have a more complex structure with vessels and fibers, which makes them stronger and denser than softwoods. Because of that, they are perfect for things like flooring, cabinets, furniture, and other heavy-use items. Some common woods or hardwoods that we are about to discuss are oak, maple, cherry, mahogany, and even rubber wood. These are the kinds of woods that not only look great but also last a long time. Let's start with oak. An oak is a hardwood tree belonging to the genus Quercus within the beech family. They are known for their strong, durable wood, often used in construction, furniture, and other applications. Oaks are also known for their acorns, which are a food source for various animals. Oak is one of the most reliable hardwoods when it comes to building houses. It is super strong, dense, and long-lasting, which is exactly what you want when you are building something that is meant to stand for decades. Oak is used for structural beams that help hold up the frame of a house, especially in traditional timber frame buildings. It is incredibly strong and can support heavy loads. Next is maple. Maple wood is a hardwood known for its strength, durability, and fine grain, making it suitable for various applications like furniture, flooring, and musical instruments. It comes in hard and soft varieties, each with unique characteristics, and is appreciated for its ability to take on various finishes. Maple is strong too, But what makes it really useful in homes is how smooth and fine the grain is. It is ideal for parts of the house that people touch or see up close every day. Maple is often used for hardwood floors inside bedrooms, hallways, or upper level of the house. It is tough, but its light color and smooth texture make a home feel clean and mahogany is a valuable hardwood known for its reddish-brown color, straight grain, and durability. It is a popular choice for furniture, musical instruments, and other fine woodworking applications. Mahogany trees are typically found in tropical regions with various species like African and Honduran mahogany. While it is not often used to hold up a house, it is a popular choice for parts that make a house feel luxurious and high-end. Mahogany is often used for main entrance doors. It is dense and weather resistant, so it holds up well against rain, sun, and wind. Next is cherry wood, particularly from the black cherry tree or Prunus serotina, is a prized hardwood known for its rich, warm reddish-brown color and fine straight grain. It is popular for furniture, cabinetry, and other woodworking applications due to its durability, workability, and aesthetic appeal. Now, think about a home with a high-end, classic-looking cabinetry in the kitchen. Those cabinets are often made from cherry wood, which is strong enough to last for years but also easy to shape and polish, which makes it perfect for detailed work like kitchen furniture or trim. Lastly, we have rubber wood, which is also known as parawood or plantation hardwood, that is light-colored, medium-density hardwood, which is obtained from the para rubber tree or Hevea brasiliensis. Rubber wood is commonly used for furniture, flooring, and other wooden products. So once the tree stops producing latex or the white liquid driven out of the tree, the wood is harvested. So it is actually quite eco-friendly. So rubber wood is widely used for making furniture and flooring, especially in more affordable homes.
Hello everyone, I am Joseph Dumangan Jr. and our next topic is all about softwood. So softwood is from gymnosperm trees such as conifers. Softwood is an organic product frequently used in the construction industry. It's produced from gymnosperm trees and is renowned for being lightweight yet considerably strong and durable. So para maintindihan natin ang ibig sabihin ng gymnosperm, ang gymnosperm ay ang group of non-flowering plants or sila ang mga puno na may nakalantad na seed or buto. Ang mga softwood ay halos evergreen like pine trees, spruce, cedar, and gymnosperm means naked seed like yung pine trees. So next, we go to the characteristics of softwood. First one is the lightweight. Under the lightweight, softwood is generally lighter than hardwood, making it easier to handle and process in various applications. So, easier to handle ang softwood due to its lower density and simple cellular structure, making it easier to cut or shape and work with. Softwood also tend to have more uniform grain pattern and are less likely to split when nailed. The next one is the growth weight. Under growth weight, coniferous trees grow faster than hardwood, allowing for quicker harvest and replenishment of resources. So, dito naman is mabilis siyang lumaki compared sa hardwood. And lastly, the workability. Softwood is easier to cut and shape, making it popular choice for carpentry and crafting projects. So dito is halos ginagamit sa carpentry ang softwood dahil mas madali siyang mahati or mas mabilis siyang gawin. Tulad ng paggawa ng isang bagay, tulad ng mga upuan, cabinets, and tables, etc. So dumako naman tayo sa uses ng softwood. Number one is the construction. Under construction, softwood is extensively used in building homes, and structures due to its strength to weight ratio and cost effectiveness. So sa construction naman, ang softwood ay halos ginagamit sa paggawa ng mga wallings, ceilings, floorings, and even trusses. Softwood is mostly used in construction due to its lower density. And number 2, we have furniture. Under furniture, many furniture pieces are made from softwood. It is of staining and finishing makes it a desirable material for manufacturers. So, sa furniture naman is ginagamit ang softwood sa paggawa ng mga gamit like tables, chairs, and other furnitures. And number 3, we have the paper production. Under paper production, softwood fibers are essential in paper making, yielding strong and durable paper products. So, under naman sa paper production, ginagamit ang softwood para gumawa ng mga papel, including newsprint and writing papers. So, meron pong mga proseso ng paggawa ng mga papers. So, dumako naman tayo sa advantage ng softwood. Number 1, cost. Softwood trees grow faster than hardwoods, leading to lower production costs and making softwood more affordable. Number 2 is the availability. Softwood trees are more abundant and readily available than hardwood trees. Number 3, versatility. Softwood is suitable for a wide range of applications, including interior and exterior construction, furniture, and paper production. Lastly, we have the sustainability. The faster growth rate of softwood trees makes them a more sustainable option for our large-scale construction projects. So, lahat naman siguro ng mga advantage ng mga softwood is understandable. Sila po ay madaling mahanap and dahil sa halos mabilis silang lumaki, ito ang halos na ginagamit sa mga carpentry industry or construction industry. And isa naman po sa disadvantage ng softwood is it has low density leading to reduced durability and it has low aesthetic appeal compared to hardwood. So mas matibay po yung hardwood compared sa softwood. Let's go to the examples of softwood. Number 1, we have the pine woods. Pine wood is the famous of all types of softwood as one of the most widely available timber woods in the world. Pine is prized for its versatility, easy availability, ease of work, and good looks. So ito po yung mga halimbawa na products ng mga pine trees, cabinets, chairs, and shelves. Number 2 examples, we have the cedar. Cedar is a nutty softwood, red-brown color with light stakes, aromatic and moth repellent, popular wood for lining drawers, chests, boxes, and brittle wood. So yung cedar wood po is mostly used sa mga paglining ng mga drawers, chests, and boxes. So ito po yung mga halimbawa na products ng mga cedar woods like kitchen boxes and chairs. Third one is the redwood. Redwood trees are among the tallest in the world, reaching height of over 100 meters. The wood is renowned for its resistant to decay and attractive appearance. Redwood is frequently used for outdoor furniture, decking, and sliding, offering both beauty and durability. So sa redwood po is dahil sa ganda po ng kahoy na ito, mostly ginagamit po ito sa outdoor furnitures. So ito po yung mga halimbawa ng redwood, guitars, acoustic guitars, electric guitars, and even po sa paggawa ng tables, ginagamit po yung redwood. And lastly, we have the Douglas fir. Douglas fir wood, a strong and versatile softwood, is widely used in construction and woodworking due to its strength, durability, and ease of working, making it suitable for various applications like beams, floorings, and furnitures. So ang Douglas fir po is ginagamit sa maraming various applications like nga yung sinabi na beams, floorings, and furnitures. Isa po sa mga halimbawa ng mga products ng Douglas fir is yung ito po, yung tables, even floorings, ginagamit po yung Douglas fir, and even the trusses. So let's move on to the challenges in the softwood industry. First one, the pest threats. Softwood resources are susceptible to pests such as the pine beetle, which can significantly impact supply and health of forests. So isa sa challenges in softwood industry is yung pest threats. So ang softwood is madaling kapitan ng pest like itong pine beetle na pwedeng sirain yung woods natin. Number 2 is the climate change. Challenges in climate can affect growth rates and the habitats of coniferous trees, posing risk to the softwood supply chain. So nakakapekto naman po yung climate change sa softwood industry dahil halimbawa po kung sobrang init ng panahon, pwede pong makadulot ng sunog. Like yung nangyari mismo sa Benguet na nagkaroon ng sunog dahil sa sobrang init. And lastly, we have the market volatility. Fluctuations in demand and pricing can create instability for softwood suppliers, influencing industry dynamics. So, yun po.
Good day everyone, I am Catherine A. Santiago and I will be discussing about the wood seasoning. So first, let us define what is wood seasoning. Wood seasoning is the process of drying the timber to reduce its moisture content, making it suitable for various applications like construction, furniture making, or burning. So wood seasoning is the drying of wood to make it strong and ready to be a building materials. Next is, why is it needed to season woods? Fresh or newly converted wood contains a lot of moisture, and if it left in this state, it will lead to twisting, warping, and splitting. It can also be open to rotting and it will be vulnerable to insect attacks that can lead to damaging the wood. So there are two methods of wood seasoning. First is the air seasoning or the natural seasoning, and second is the kiln seasoning or the artificial seasoning. So first is the air seasoning. Air seasoning is a way to dry wood slowly. It takes place in a big open-sided shed. We stack the wood inside, leaving the spaces between the pieces. The wind blows through and the sun shines on it, gently drying the wood over a long time. It is a cheaper way to dry wood than using a special oven or a kiln, but it takes much longer. Next is the kiln seasoning. Kiln seasoning is like using a special oven to dry wood quickly. We put the wood on a cart and roll it in a big closed room. Then, we use heat and steam to dry it up much faster than letting it dry naturally. So the image on the top is what we see physically, and the image below is the process of how it is seasoned. If we make an example relating to it, it's just like drying out our hair. We can let it dry out by the air, or we can use a hairdryer or blower to make it dry faster. So next are the key factors that we should consider in seasoning woods. So first is the type of wood, because different woods dry at different rates. Same woods are denser and it takes longer to dry than others. This affects the overall drying time of the wood. Next is the thickness of wood. Thicker pieces of wood takes much longer to dry than the thinner pieces. And next is the desired moisture content. The final moisture content determines how strong and stable the wood will be for its intended use. Too much moisture and the wood will be weak and prone to rot, and too little and the wood can be brittle and prone to cracking. So the goal is to find the right balance. Next is proper stacking. Proper stacking allows air to circulate around the wood, prevent mold, and ensuring even drying. If it's stacked improperly, some parts of the wood might dry faster than others, causing warping or cracking. So, last one is the ventilation. Good air circulation removes moisture efficiently and prevents molds. Proper ventilation is vital for even drying and minimizing the risk of wood damage. So, last, let us know why it is important to season woods. First is of course reduces moisture. Lowering moisture content is the primary goal. Wet wood is prone to rot, mold, and insect infestation, like I said earlier. Drying it prevents these issues. So next is control shrinking percentage. Wood shrinks as it dries. Controlled drying minimizes the amount of shrinkage, preventing warping and cracking. This is crucial for structural integrity of the final product. So next is improved structural integrity. Dry wood is stronger and more stable than wet wood. This improves strength and is crucial for construction and furniture making. So next is enhances workability. Dry wood is easier to work with. It is less likely to split or splinter when cut, shaped, or nailed. So last is it extends lifespan. By reducing moisture and improving structural integrity, seasoned wood is far less susceptible to damage and decay, therefore significance in extending its lifespan. So, we all know that wood is important to our environment as it is one of our natural resources. But in our field of engineering, cutting wood is inevitable. So wood seasoning may not be prevented, but it will lessen the cutting of trees as it extended the lifespan of the woods or logs and it can be used longer.
Good day, everyone. I am Philomena Dalunag, and my report for today is all about engineering wood. According to professional builder Jordan Smith, engineered wood is lumber that, although it comes from wood, it's been processed to be something slightly different and perform in a different way, oftentimes better way than what just the raw wood would perform. Engineered wood is used in a variety of applications, from home construction to commercial buildings to industrial products. And as the name implies, engineered wood products are carefully tested for strength, durability, and resistance to moisture. Some products are made with waterproof adhesives specifically for outdoor use. One familiar engineered wood product is plywood. Plywood is made up of layers of veneer that are glued together with heat and pressure to form panels. The veneers are cross-laminated by alternating the direction of the grain of each layer. The result is one of the most useful building products on the planet. Thin, wide, flat plywood panels are ideal for adding strength, stiffness, and stability to floor, wall, and roof framing. Plywood also makes superior shelves, cabinet boxes, and stair components. And when it comes to strength and stability, compared to solid wood, plywood boasts greater strength and dimensional stability due to the opposing grain directions. This reduces warping and cracking, making it a reliable material for various applications. And in terms of versatility, plywood comes in a various grades, thicknesses, and wood types, catering to a wide range of uses. Hardwood plywood offers exceptional strength and aesthetics, while softwood plywood is a more cost-effective option for general construction purposes. Next example of engineered wood is blackboard. Blackboard is a type of engineered wood panel made by gluing together softwood strips to form a core, which is then sandwiched between two layers of wood veneer. This construction provides strength and stability, making it suitable for various applications like furniture, doors, and wall panels, partition or kitchen worktops which have no intermediate supports. Blackboards can be worked with standard tools. It is easily sewn and has good screw holding properties. It can be resistant to warping if both sides have similar treatments. It can also be boiling waterproof and eco-friendly. Another example of engineered wood is wood veneers. In the simplest of terms, wood veneers are thin slices of natural wood generally less than 1/40 inches thick. These veneers are typically pressed onto or laminated to thicker core materials such as plywood, particle board, and MDF to create structural panels to be used in place of thicker hardwood lumber. And one of the main reasons for using wood veneers is to cover less valuable wood with something of higher quality and appearance. Veneers do not absorb moisture or change color when exposed to sunlight at the same levels as the other materials, so it will not warp. Solid wood is quite vulnerable to absorbing moisture, and veneer can provide a layer of protection. Additionally, veneer is economical because many wood veneer sheets can be produced from one piece of lumber. Wood veneer pieces use less natural wood than solid wood, making them environmentally friendly. Using veneers also reduces waste from sawdust and other small wood pieces during building and construction. Wood veneers can be stained and finished at the same as solid wood. The next example of engineered wood is laminates. Laminated wood is usually built by the parallel gluing of lumber boards in a variety of sizes and shapes according to intended use. The main products are load-carrying members such as beams and arches. Parallel glued veneers are sometimes used to produce specialized items. Laminated wood is a popular choice for furniture and floors because it is durable and easy to care for. And one of the primary benefits of wood lamination is that it can save you money on labor costs. Laminate flooring is a popular choice because it offers the look of real wood at a fraction of the cost. Laminate is also much easier to install than hardwood, making it an excellent option for do-it-yourselfers who want to tackle a flooring project independently. In addition, wood lamination is more resistant to scratches and scuffs than hardwood, making it a good choice for families with pets or large businesses. And because it doesn't require sanding or refinishing as hardwood does, lamination is a low maintenance option that will keep your floors in excellent conditions for years. However, it can be damaged by water, heat, or scratches. So it is crucial to repair the damage quickly to prevent the laminate from peeling or cracking. But with proper care and maintenance, it can last for many years.
Hello everyone, this is Izzy Subido and we are now going to explore the continuation of the types of engineered woods. We have here number 5, particle board or chipboard. So we have here yung composition niya which is made from compressed wood chips, yung mga maliliit na na-produce from large na wood products like logs, and sawdust, yung mga powdered particles from wood mixed with glue or resin during a thermal compression process. In its structure naman po, it features visible wood waste such as wood chips in its makeup. In its application naman, it is widely used in furniture making, extensively in kitchens, cabinets, shelves, countertops, and floor underlayment. There is also enhanced properties of chipboards. It can be modified for moisture resistant that can withstand exposure to humidity pero hindi po siya waterproof. Another improvement is for fire resistant. Minsan nilalagyan nila ito ng mga additives or treatments para resistant din siya sa sunog. And also, suitable for soundproof panels. Dahil dense yung composition niya, nire-reduce na po yung noise just in case na gamitin mo siya as walls in studios. So, ito po yung mga example po ng ating chipboards. Makikita po dito na visible po yung mga wood chips dito sa illustration or sa images na nakalapag dito sa ating PPT. Ito naman po yung ating advantages ng ating chipboard. It is easy to transport and handle since compact na siya and lightweight. It is also a cost-effective option and also has insulating properties and suitable for internal uses. And the last one is its malleability, or it is malleable, that can be resized or shaped using cutting machines and drills. Pwede po siya i-resize, i-cut po siya into small pieces. So we have also here its disadvantages. Number 1 is its low moisture resistant. Yung mga hindi po na-enhance na chipboard po ito na mas mura. Also, lacks aesthetic appeal. Plain lang po siya mismo, visible din na ang kanyang layering. It is also low tolerance to heavy loads and pressure, and also more prone to damage compared to other types of wood like MDF and HDF na tatalakayin po natin later. So, dito na po tayo sa medium density fiberboard or MDF. Its composition. It is made by combining sawdust, wood chips, and organic fibers from wood and plants, then pressing under high pressure. Kung sa chipboard po ay thermal, yung compression niya, dito po ay high pressure lang po. So, in its application, it is widely used in building materials for residential and commercial projects. It is also commonly used to make cabinets, furnitures, walls, panels, and decorative items, and doors. Niu-utilize rin po siya in acoustic enclosure, soundproof na rooms like studios, speakers, and bass speakers due to its heat and sound insulation properties. Pero may limitation din po siya, which is not practical for flooring applications like laminate or parquet floor, kung saan matatakil din po natin later sa kanyang disadvantages. Mayroon din po tayong major disadvantage, wherein its high density make it significantly heavier than plywood and chipboard, since compacted po siya using mechanical force without heat compared to chipboard na heat and pressure naman po. So these are the example of MDF. Makikita po dito na mas compressed at hindi po visible ang yung wood chips niya compared to chipboard. We have also here the advantages of MDF, which is the first one, sound insulation, widely used in music industry. The second one is moisture and dryness resistance. It also offers high quality at a low price and resistant to termites and other pests due to chemical treatment like resin binding to enhance its properties. Of course, may disadvantage rin po tayo sa ating MDF. It is difficult to repair. It may also absorb moisture faster than a natural wood. The chemical in its composition are less suitable for children. And also the last one is may connection issues rin po siya, wherein glues and screws make connection challenging since prone po siya sa initial cracking with nails, which is limitation niya rin po in terms of adhesives. So, the last common type of engineered wood is HDF. Number 7 is HDF or high density fiberboard. The composition of this product is made from homogeneous wood chips combined with synthetic resin and adhesives. It is pressed under high temperature and high pressure. Parang combined po yung compression technique na ginamit sa chipboard and MDF. Kaya mas dense and compact po siya in conclusion. The thickness of this product is typically ranges from 3 to 8 mm. Matipis lang po siya, parang MDF lang na mas enhanced version po, with a thickness of less than 1 cm. In terms of strength and durability naman, it offers a superior strength, structural integrity, and resistant to moisture and impact, which is also better than MDF. In its application naman, it is a reliable alternative to wood and plywood in projects where durability is required. It is often used for kitchen cabinets and bathroom vanities due to moisture and humidity resistance. So we have here the examples of HDF. More on ginagamit po siya sa flooring and sa kitchen po. We have also here the advantages of HDF. The first one is hard and solid. Make it making it ideal for multi-layer food flooring. Another one is its smooth surface and also highly receptive to coloring. Nare-retain po yung kulay niya kapag ginukulayan po ang HDF, unlike chipboard. So we have here also suitable for frames, boxes, shutters, and wardrobe shelves. Aesthetic din po siya, and also the last one is highly resistant to termites due to chemical treatments gaya ng MDF rin po. These are also the disadvantages of HDF. Hindi po siya waterproof. Nagsaswell po siya with high humidity exposure. If it's exposed to water, the fibers will swell and the damage will tough to fix. It is also limited for outdoor use, unsuitable for open spaces due to high moisture absorption. Take note, hindi po siya waterproof kundi moisture resistance lang. So, i-cover ko na rin po yung ating next topic, which is advantages of engineering woods. Number 1 is the consistency, uniform density and free from natural defects like knots or warping. Also, dimensional stability. It is less prone to expansion and contraction due to humidity and temperature changes. Another one is the resource efficiency. It utilizes fast-growing tree species and wood waste, reducing reliance on old-growth forests. And also strength, wherein a strength to weight ratios compared to solid wood o yung mga natural woods like logs or timbers na engineered na rin po. The next one is its size flexibility. It can produce large panels and structural members not possible with solid wood, and kahit yung mga wood waste na hindi na rin po masasayang. The next one is its cost effectiveness. It is also more affordable than high-grade solid wood. More affordable na, durable na rin. And also, the last one is the customization. It can be tailored for manufacturing wherein it allows specific performance characteristic. Pwede siyang lagyan ng mga adhesives and chemical treatment for durability and enhancement. So, we have here the conclusion of advantages of engineering woods. Engineered wood is sustainable because it allows you to achieve or exceed the same density and strength of old-growth timber, but with lumber made from young trees. It also reduces waste because it uses all the parts of tree, even defects or pieces left over from cutting dimensional lumber. Engineered wood can be also stronger than dimensional lumber because of its high density and layers of grain running in different direction. Also, some engineered woods can resist warping and splitting more than dimensional lumber. That's all. Thank you.
So, hello everyone. I'll be reporting about the disadvantages of engineered wood. So, we have here number 1, susceptibility to rot and decay. So, alam naman natin ang wood is prone to rot and decay lalo na kapag na-expose sa moisture, which can lead to structural weaknesses and potential collapse. So, isang example nito is kapag meron kayong mga nakitang old house, makikita nyo doon sa labas niya is nag-rot and nagde-decay. Nakaka-apekto ito sa structural ng isang bahay. So next is the vulnerability to insect damage. So alam naman natin ang wood is susceptible na mag-damage sa isang structure kasi parang inaanay nito yung mga wood such as termites and carpenter ants, which can compromise its structural integrity. So, alam ko naman na nakakita na kayo ng ganito, yung mga wood na inaanay. So, ito talaga yung pinaka-disadvantage ng wood kasi madaling maanay. So, next is limited strength and durability. So, ang wood has limited strength and durability compared sa mga ibang other building materials, making it less suitable for large-scale or high-load applications. So, basically, ang wood is hindi talaga siya suitable para sa mga large-scale or high-load applications. So we have here a table. So ang table na ito is meron siyang different classes. So the class 1 is, ang designation nito is very durable, which can last to 25 above years, and the class 2 is durable and which can last to 15 to 25 years. So number 3. Class 3 naman is moderately durable, which can last to 10 to 15 years. And number 4, or class 4, is slightly durable, which can last to 5 to 10 years. So, ang pinakalas is the class 5, which is not durable, which can last to 0 to 5 years. So number 4 is sensitivity to moisture and temperature changes. So ang wood is very sensitive lalo na sa mga moisture at temperature, which can cause it to rot, crack, or shrink. So alam ko naman na nakakita na kayo ng mga kahoy na nag-iiba yung shape nito dahil ito sa change of temperature. So next is number 5, fire risk. Wood is combustible and can fuel fires, making it a potential safety hazard in certain applications. So alam naman natin na ito talaga yung pinaka-disadvantage ng wood kasi nga prone siya sa fires. So number 6 is the maintenance requirements wood. So ang wood, it requires a regular maintenance to protect it from damage and extend its life. So ang wood is kailangan talaga ng laging pagme-maintain para ma-avoid yung mga damages or yung mga insects na makakasira nito. So for the next topic, I'll be explaining the wood preservation. So what is wood preservation? Wood preservation is the process of protecting wood from decay, rot, and insect damage. Wood preservation is essential to extend the lifespan of wood and prevent damage. So basically, ang wood preservation is a process para maprotektahan yung wood sa pag-decay and para ma-extend yung lifespan nito. So, we have here the types of wood preservation. There are 2 types, which is number 1, the chemical preservation. So, from the word chemical preservation, it uses chemical to protect wood from decay and insects. So, number 2 is non-chemical preservation. It uses natural or non-toxic methods to protect wood. So we have here tar oil preservatives. It is normally dark liquids made from coal tar mixed with chemicals, suitable for outdoor use, black or brown color, applied by brushing, spraying, dipping, or pressure treatment. So example nito is yung creosote. Isa siyang type of preservative na na-derive from coal tar, used to protect from decay, rot, and insect damage. So, we have here the advantage and disadvantage of tar oil preservatives. So, ang advantage ng tar oil is toxic to fungi and insects, easily absorbed by the wood, long-lasting siya, and mas mura and inexpensive. So, ang disadvantage naman nito is malakas yung amoy, toxic siya sa plants, and mahirap i-paint over. So, number 2 is waterborne preservatives. So, ang waterborne preservatives ay made sa mixture of toxic salts, copper and zinc, and water. So, kapag ina-apply ito sa wood, yung water is nag-evaporate, leaving toxic salts to act as a preservatives. So, usually pressure impregnated, chemical protection given, uses structural timber and furniture. So, ang example nito is ang CCA, which stands for chromated copper arsenate. Siyang water-based preservative na nagko-contain ng chromium, copper, and arsenic, used to protect wood from decay, rot, and insect damage. So, so yung pangalawa is ang ACQ, which stands for Alkaline Copper Quaternary. Isang water-based preservative na nagko-contains ng copper and quaternary ammonium compounds used as an alternative to CCA. So, meron ding borates, isang type of preservative na nagko-contain ng boron, ginagamit to protect wood from decay, rot, and insect damage. So, makikita nyo dyan yung examples, yung pictures ng mga examples. So, andyan yung CCA, yung ACQ, and yung borates. So, we also have here the advantages and disadvantages of waterborne preservatives. So, ang advantage ng waterborne preservatives is colorless, odorless, and can be painted over. So, ang disadvantage naman ng waterborne preservatives is timber needs to be dried out by kiln after treatment. It can cause swelling, and salts can be washed out from the wood. So, number 3 is the solvent-based preservatives. So, ang solvent-based preservative is made from toxic chemicals dissolved in a liquid other than water, usually white spirits. So, after treatment, yung solvent nag-evaporate and leaving the preservatives in the wood. It can be applied with a brush or with a spray gun. So, this is usually used in furniture and all external woodwork. So, ang example nito is yung pentachlorophenol or penta. Solvent-based preservative na ginagamit para maprotektahan yung wood from decay, rot, and insect damage. So, makikita nyo dyan yung picture ng kung paano ginagamit yung pentachlorophenol. So, we have here yung advantages and disadvantages ng solvent-based preservative. So, ang advantages nito is resistant siya sa leaching, can be paint over, and can be used indoors. Ang disadvantage naman is may malakas na smell, can be a fire hazard, and expensive.
Good day everyone, I'm Jan Patrick Kijatan, and let's proceed to methods of application, without pressure or with pressure. There are three methods of application, which is brushing and spraying, dipping, and pressure treatment. Let's proceed to brushing and spraying. Preservatives can be applied using a brush or a spray gun. This method is the easiest to use and is not too costly. The preservative, however, doesn't penetrate deep into the wood, and the treatment needs to be repeated regularly to keep the wood protected. Dito sa brushing and spraying, it only requires minimal equipment and is easy to perform. However, yung depth ng penetration is around not exceedingly 2.5 mm. Next is the immersion and dipping. The wood is placed into a container of preservative, and the wood absorbs the preservative or chemicals over a specified period of time. The immersion can be done for a short time, which is called dipping, and steeping naman for a long period. Kapag dipping, dinidip lang nila yung wood for just a few seconds to several minutes. While sa steeping naman, nagre-range yung pagkababad ng wood for several days to weeks. The immersion process penetrates better than brushing and can be even more effective if the preservative is heated. Mas effective yung immersion or dipping kaysa sa brushing at spraying because mas na-absorb ng wood yung preservative sa pagkababad ng preservatives. Punta naman tayo sa pangatlong method, which is pressure treatment. The most effective method of applying preservative is by forcing the preservative into the wood under pressure. The pressure can come from inside vacuum or outside pressure. Yung process treatment nito is the wood is placed into a sealed treatment vessel and a vacuum pump removes air from both the vessel and the wood's cells cavities. This creates space for the preservative solution and the vessel is filled with the preservative solution under vacuum, ensuring that the wood is fully immersed without introducing air. This is the most effective method for applying wood preservative because it ensures the deep and uniform penetration to protect against decay, insects, and environmental factors. Proceed naman tayo sa importance of wood in civil engineering works, which is structural applications, cost and efficiency, insulation and energy efficiency, and sustainability and environmental benefits. First is structural applications. Load-bearing structures. According to Wagner meters, wood's strength and resilience make it suitable for beams, rafters, and joists in load-bearing applications. Next is concrete forms. Wood is used as concrete forms, providing a cost-effective and easily adjustable support for pouring concrete, as noted by TRC. Next is temporary structures. It is often used for site offices, storage sheds, and temporary supports. Karaniwang ginagamit ang wood sa civil engineering para sa mga struktura tulad ng framing ng bahay, sahig, bubong at maging sa mga tulay. May mataas itong lakas kumpara sa bigat nito, kaya angkop ito sa magaan hanggang katamtamang bigat ng mga struktura. Ang mga produktong kahoy tulad ng glulam at cross-laminated timber or CLT ay nagpapausay sa kapasidad nitong magdala ng bigat at nagbibigay ng mas maraming opsyon sa disenyo. Madali rin itong putulin at ikabit, kaya paborito at hindi na ito nawawala sa maraming proyekto. Next importance is cost and efficiency. Reduce cost. Using wood can decrease construction expenses by up to 30% on and minimize waste. Next is faster construction. Wood's lightweight nature and ease of handling lead to faster construction timeliness, often taking half the time compared to masonry construction according to TRC. Wood is generally more cost-effective than steel or concrete, especially for residential and low-rise construction. It is widely available, easy to transport, and requires less specialized labor and equipment to install. Prefabricated wood components can speed up construction timelines and reduce labor costs. Ang wood din ay isang renewable resources na maaaring tumubo muli. May potential din ito para sa mas mahabang gamit at matipid sa kabuuang gastos. Last na importance is insulation and energy efficiency. Thermal insulation. Wood provides better insulation than concrete or steel, reducing energy consumption for heating and cooling, as highlighted by designing builds. Next is acoustic insulation. Wood also offers good acoustic insulation, contributing into a more comfortable indoor environment. Wood is natural insulator due to its cellular structure, helping to reduce heat transfer and improve energy efficiency in buildings. Kumpara sa mga materyales tulad ng bakal o konkreto, mas epektibo itong nagpapanatili ng tamang temperatura sa loob ng gusali. Sinusuportahan din nito ang paglalagay ng dagdag na insulation nang hindi naapektuhan ang tibay ng struktura. Dahil dito, mahusay ang kahoy para sa mga disenyo ng gusali, matipid sa enerhiya at mas makakalikasan. That's all. Thank you.